Off-grid systems are sized based on the energy demand of the appliances to be connected. A system designer can only design a system to meet the power and energy needs of the customer. The designer must therefore use load assessment process to understand the needs of the customer. Load assessment is critical. Undersized systems will not deliver what they are expected to. Oversized system will cost more than necessary. You need to calculate the electrical energy usage with the customer, and at the same time you need to educate him. Many systems have failed over the years not because the equipment has failed or the system was badly installed, but because the customers believed they could get more energy from the system than what the system could deliver. It failed because the customer were unaware of the power and energy limitations of their systems. The problem is that the customers may not want to spend the time determining their realistic power and energy needs, which is required to successfully complete a load assessment form. They just want to know how much for a system to power my lights and TV. Electrical power is supplied either from the batteries to produce DC or via an inverter to produce AC. Electrical energy usage is normally expressed in watt hours or kilowatt hours. To determine the daily energy usage for an appliance, just multiply the power of the appliance by the number of hours it will be operating per day. The result is the energy consumed by that appliance per day. Remember, energy equal power multiplied by hours. Appliances can either be DC or AC. You will have to undertake load assessment for each type of appliance, DC and AC. At the end of the load assessment, you should have identified DC and AC loads. You should also have determined DC and AC appliances' contribution to the load demand. This is the total watt of each type of appliances. The last you should determine is the energy demand for each type of appliance. So you will have identified DC and AC loads, determined DC and AC appliances contribution to the load demand, and you should have determined the energy demand of each type of appliances. Let's assume a house equipped with 12 DC lamps 5 watt each. The lamps are on 6 hours per day. One TV rated at 150 watt and used 6 hours per day also. One computer 150 watt also, and the computer is on 4 hours per day. One fridge 80 watt used 12 hours per day. We will go further in our design process using this house and its load as our example. First of all, load assessment. The goal is to determine power demand and energy need. You have to do it in 5 steps. Step 1, DC power demand. Step 2, DC energy demand. Step 3, AC power demand. Step 4, AC energy needs. And step 5, total energy needs. So, for the step 1, DC power demand, you will have to multiply the number of lamps, which are our DC appliances, by their wattage, 5 watt. Step 2, DC energy need. You have to multiply the power demand you obtained, which in our case is 60 watt, by usage time, 6 hours for our DC load, our lamps. You obtain DC energy needs equal to 360 watt hours. Step 3, AC power demand. Multiply the number of each type of AC appliance by its wattage. Step 4, energy needs. Multiply the number of each type of AC appliance by its wattage and its usage time. Step 5, total energy needs. Sum up DC and AC energy need. This will lead you to 2820 watt hours. So all the calculations are downloadable